In this example, we are considering the SAT reasoning test. We are given that the SAT is a normally distributed test, and we're also given the results for 2009. We're given the results in particular for our exercise. So here is the question. We randomly select 16 SAT test takers for 2009. We want to find the probability that the mean of those 16 writing scores was between 450 and 550. So that is the same as saying that we want the probability that the mean is, that the variable mu, the mean, is between 450 and 550. Now, our population, that of SAT scores, happens to have a mean from the table, I'm getting this from the table, of 493 and a standard deviation of 111. The probability that we're looking for is on the random variable mu, which in this case is the distribution of the means. This will employ the central limit theorem because we're looking at a distribution of means. The central limit theorem does apply because our original distribution, that of SAT scores, is normal. So the central limit theorem applies. So the central limit theorem says that the distribution of means happens to be a normal distribution. So we picture it as such. Now the mean of this distribution of means happens to be the same as the mean of the original distribution. So the mean of the distribution of means is the same as the mean of the original distribution where our 16 scores come from. So that's the same as 493. 493. In this distribution, the standard deviation by the central limit theorem is the same as the standard deviation of the original distribution over the square root of the sample size, the square root of n. Now, so sigma in our original distribution was 111. Our sample size is 16 because there are 16 data values. So you get 111 over square root of 16. That's the same as 111 over 4. When you perform this calculation, you obtain 27.5. So the standard deviation of our distribution of means is 27.5. So now we proceed to treat this problem as a normal distribution problem. We want the probability that the mean score is between 450, 450 being to the left of 493, 450, and 550. Let me elongate this a little bit. So we'll say 550 is over there. So what we want is the area under the curve between 450 and 550. In order to solve the problem, we'll have to convert this distribution into the standard normal distribution using z-scores. So we proceed to compute the z-score for 450 and the z-score for 550 so that we can study the problem in a standard normal distribution. So for 450, z equals 450 minus the mean of the distribution. The one we're considering happens to have mean of 493 over the standard deviation of the distribution we're considering. We found it to be 27.5 When you do your calculation, this turns out to be the numerator is negative 43. So negative 43 over 27.5 is negative 1.54 95, etc. Now this is a z-score. Since we're going to employ tables, z-score tables, they are only up to the 100th place. So we're going to approximate this by negative 1.55. We run this off to the nearest 100th. So because this is a 9, this goes to negative 1.55. Now, in a similar fashion, we would like to compute the z-score for 550. The z-score for that one, after we compute it, first we plug it into our z-score formula, 550 minus the mean, 493, over standard deviation, which is 27.5. That, after the calculation, you get the 2.0504, 2.0504 and change. Again, we need to round this to the nearest 100th, so it turns out to be 2.05. So now we have our standard normal distribution. What we want is the area under this standard normal curve between z negative 1.55 and 2.05. Now the way we're going to get this area is we're going to look at the tails, this left tail, the right tail, we're going to find the area of those two tails, and then we're going to subtract those from 1 to obtain the area in the middle. So let's see, negative 1.55, what's the area to the left? According to our negative z-scores table, the area to the left of negative 1.55, negative 1.55 is 0.0606. So the left tail has an area of 0.0606. Now to find the area of the right tail, we're going to have to do the following. We have to find the area to the left of 2.05, and we're going to subtract that from 1. So the right tail is going to be 1 minus the area to the left of 2.05. The area to the left of 2.05, according to our positive z-scores table, 2.05 is 0.9798. 0.9798. Now, after we perform that calculation, the right tail turns out to have an area of 0.0202. So now to conclude, we just find the area of the middle. That area in the middle is going to be 1 minus the area of the left tail minus the area of the right tail, minus 0.0606 minus 0.0202. This results in 1 minus 0.0808. Somewhere in here I have the final result, the same as 0.9192. So the area of the middle, which is what we're looking for, the area of the middle is 0.9192, and that is the same as the probability that the mean score, the mean writing score, was between 450 and 550. And that concludes this example.